If Saturn's rings circled Earth, humans wouldn't be first to vanish. Migratory birds would. 9 billion would strike ice shards mid-flight, and red rain would fall for 3 months. But what truly worries scientists isn't this, but that the moon's orbit would be disturbed. This lovely-looking ring acts like chronic toxin, slowly killing Earth over several millennia? So how does it do that? Before answering, first know this one thing. How did Saturn's rings form, exactly? Scientists studied them for centuries, only to discover that this beautiful halo is actually the scene of a cosmic murder. In 1610, Galileo saw Saturn's rings by telescope, but views made him think Saturn had 2 ears. It wasn't until 1655 that Dutch astronomer Christian Huygens confirmed it was a ring. Since then, scientists have debated one question. Are the rings solid or made of fragments? By 1850, mathematicians proved solid rings would be torn by Saturn's gravity. So the rings are fragments. But where did those pieces come from? We now know Saturn's rings are countless ice and rock bits, from micron dust to meter-sized chunks. But almost 99% is water ice. Purity shockingly high. Ice chunks orbit Saturn 70,000 to 280,000 kilometers out, racing 20 kilometers per second. The ring is only 10 to 100 meters thick, so paper thin, yet spans 280,000 kilometers? How did it? 2 main theories. First, Saturn's rings are primordial debris from the solar system's birth, dating 4.5 billion years. Second idea, Saturn once tore apart a moon. Its debris formed the rings, which explanation is. In 2017, Cassini sent back answers before finally crashing. Cassini gauged Saturn's rings' mass and dirtiness. Though they look huge, they weigh only a third of Mimas, about 1.5 quadrillion tons in all. Cassini's data sounds like a lot, but for a giant like Saturn, it's tiny. What matters more is overall contamination level. Micrometeoroids and dust in space constantly fall on the rings, dirtying them. By measuring the amount of impurities in the rings, scientists could deduce their age, and the results shocked everyone. Saturn's rings are 100 to 200 million years old. Saturn is 4.5 billion, yet rings possibly formed post-dynasty. This means Saturn's rings are not primordial material but appeared later. So how did they form? The answer lies in a principle called the Roche limit. It's simple. Standing on Earth, gravity differs between head and feet. Your head is farther from Earth's center, so pull is slightly weaker. Your feet closer, that difference is tidal force. You don't feel it because it's tiny, but near Earth's center it becomes much clearer to you. Now picture yourself as a moon orbiting Saturn, held together by its own gravity. If it drifts too close, Saturn's tidal pull overwhelms it, and the moon is torn into fragments quickly. Critical distance. The Roche limit. For Saturn, 140,000 to 180,000 kilometers, its rings sit inside that range. Scientists think a moon entered this danger zone, and Saturn tore it apart. But how did it get so very close to Saturn? Satellites' orbits are usually stable, not drifting around. Maybe it was a collision. Imagine. About 100 to 200 million years ago, Saturn had an icy moon orbiting safely when one day, a comet flew in from the outer solar system and collided with it. Impact shifted satellite's orbit, slowly pulling it towards Saturn. After a time, the satellite reached the Roche limit, disintegrating slowly, not exploding instantly. Saturn's tides first tear the moon's surface, stripping outer ice. The ice breaks free, scattering into orbit. Debris spread, material is torn away. The satellite shrinks until it finally shatters. Debris spreads in orbit, forming a ring. That explains Saturn's rings being 99% ice. If an icy moon shattered, the rings stayed mostly ice-heavy, or the impactor comet was an ice ball. After collision, both mixed together, and then tidal forces ripped them completely apart. In either case, the resulting rings would be predominantly ice. But there's still a question. Why are Saturn's rings so bright while others seem faint? Jupiter, Uranus, Neptune have rings too, but dim. Jupiter's rings are mainly dust. Uranus's rings are like thin threads. and Neptune's rings are incomplete. Only Saturn's rings are wide and bright enough to be seen from Earth with a small telescope. The reason might be luck. Saturn took the right hit at the right time. The struck moon, by chance, was mostly just ice overall. Ice reflects strongly, so the rings look bright. Saturn's broad Roche limit holds much debris, making them very wide overall in space. All these conditions came together to create the spectacular sight we see today. Why doesn't Earth have rings? It has a Roche limit around 18,000 kilometers. Yet no large nearby body ever enters that zone. Moon is 380,000 kilometers from Earth, beyond the Roche limit, so safe. However, Earth may have once had a ring. 4.5 billion years ago, a Mars-sized object collided with the proto-Earth, creating a large amount of debris that spread out around the planet, possibly forming a temporary ring. But this ring didn't last long. The debris quickly gathered together and formed the moon. So Earth's ring only existed for a relatively short time before it became the moon. Will Saturn's rings last forever? No. Cassini found Saturn's rings falling onto Saturn, raining down like water. Saturn's magnetism and gravity drag ring material into the planet, hundreds of kilos each second. At this pace, the rings will vanish completely in 100 to 300 million years. That means we live in a lucky age today, still able to see Saturn's rings. New rings may form. Saturn has 83 moons. If another gets hit and slips into the Roche limit, a ring appears. Saturn's rings may not be eternal, but come and go in cycles. These rings we see now may be neither first nor the last. Back to first question. If Earth had Saturn's rings? Purely hypothetical. If Earth had Saturn-like rings, the moon or another large body would enter Earth's Roche limit and break up, ripped into fragments. This debris would form a ring belt above Earth's equator. Just like Saturn's rings, migratory birds will die in droves. Ring debris keeps entering the air, striking them each migration. Satellite systems would be severely affected because the orbit would be filled with debris. What's the worst fallout? If the moon was torn into a ring, Earth would lose its stabilizer. The moon today stabilizes Earth's axis and, via tides, slowly slows Earth's spin. Without the moon, Earth's axis would wobble. Climate turns chaotic. Over time, rotation may speed up over millions of years. So when you look up at Saturn and see that beautiful halo, understand that it is the remnant of a cosmic impact event, and we should be thankful that Earth's moon is far enough away from us not to be torn apart. Beautiful things often hide violent stories behind